Dr. Welcome to our digital classroom. I'm Jerry Winslet, along with Jason Leonard.
Hey guys.
And welcome to the monthly live show sponsored by HD Supply.
That's right.
What we're going to do today is we're going to talk about top service calls for gas, and it's really hard to follow that because that was like trying to be serious.
I know we should have wore the sweater.
I know, it's the whole time. We're going to talk about top service calls for gas, and we know you're very busy whenever you're doing these types of calls, so your time is worth a lot, and you don't want to be out there wasting a lot of time. So what we've done today is we've got some, before we get started, if you have questions, you can use the chat feature, which is on the right-hand side of your screen. Also below the screen, there's also some PDF outlines. You may be familiar, if you've watched this in the past, familiar with that. You can go ahead and download those and kind of follow along.
Yeah.
That's what's going to actually help you out whenever you're out in the field and you're working on these water heaters. So what we're going to do today is we're going to talk about those top service calls. Now, the first thing we want to do is, there's a lot of calls that you're going to get, especially this kind of time of year, because, the changing of the season, the water's colder coming in, so you may have water heaters that people think are leaking, and they're actually, thermal expansion.
Yeah, that's a really good point. This time of year, if things are going to go wrong with a water heater, right, as far as functionality, this is when it happens.
Right.
We're in the winter season. We're in the holidays. People have a lot more, family in. There's a lot more people in the home using hot water. So when you see these type of issues, this is really the time of year where we see that spike in these type of calls.
Yeah, so you have to kind of look at the calls that come in, and you have to kind of troubleshoot the call before you actually get into the problem with the heater, because it may not even be heater related. So really, what does the customer mean whenever they say they have no hot water? Because it may mean, in some cases, they may not have any water at all, but to them, they have no hot water.
Yeah, that's an excellent point, being able to troubleshoot that call, because most of the time, that end user, the tenant, whoever it is that's calling, they don't know how to tell you what's wrong, right? They know that they have no hot water, so that may be the only explanation that they can give you. However, if they've been attempting some things on their own, trying to relight or something like that, they may be saying other things that they think is actually a reason for the no hot water.
Right.
But the number one reason is going to be, they go to the shower, they go to the faucet, they turn on the hot water, and they just have no hot water.
Yeah, you may hear it all different types of ways. But it really boils down to no hot water, because they may call you, say, well, I can't relight my pilot won't stay lit, things like that, and that really is the second problem. The first problem is they don't have any hot water. That's how they had to go down there and try to relight it in the first place.
Yeah, the no hot water is the symptom.
Right.
Right. So that's what, just like when you go to the doctor, you say, well, my elbow hurts.
Yes.
Right. Well, that's the symptom. Well, maybe it's tennis elbow, maybe it's whatever the case may be. No hot water is the symptom. What we have to do is figure out what the problem is.
And that is our number one call, and that's really what we're going to concentrate on today. We're going to start with the mechanical style gas valve, atmospheric gas water heaters, because they're still out there, so we want to go through that. And then we're going to end the show with the electronic gas valve, the new gas valve, and kind of walk you through that. Again, you can download those PDFs, and if you have any questions, go ahead and type those in on the chat feature, and we'll get to them as they come in, so because we are live. All right, so let's talk about the mechanical style gas valve. It's been out there, it works. If I'm a service guy, because I do many different things, not only just water heaters,
Absolutely.
I'm doing other things maybe in an apartment complex. What's the first thing I do when a tenant calls and I've already verified that I have no hot water in the entire building? Because that'd be the first thing I would really do.
Yeah, that's a great point right there. When we talked about troubleshooting the call, we need an accurate description of what's actually going on. When they say no hot water, is that everywhere? Is that every single faucet in the residence? Maybe they have hot water in a sink, but not in the shower, right? That's not a water heater issue. The water heater can't determine where it sends the hot water.
No.
If it's making it, then it's making it. So that's a very important question. Do you see this phenomena happening in the entire residence? Now, once we determine, yes, there's absolutely no hot water, the water heater's not producing hot water, the first thing that we want to do is physically go to the heater, in terms of mechanical style.
Right.
And as you pointed out, these have been out for a long time. The design here really hasn't changed over the past 20 or 30 years until recently when we get into electronics. So you guys probably see a lot of these out in the field, and you will continue to do so for quite some time. The electronic stuff is starting to become more predominant, but these are still out there in large numbers. Now this one really can't communicate with you in terms of the valve. So the first thing that we're going to have to do is just come to the heater and see if we actually have a pilot light, right? We know that we have to have a pilot light in order for the main burner to light. So if we have no hot water, first my assumption is going to be maybe we've lost the pilot, right? Maybe the pilot needs to be lit. So we're just going to come to the heater, look inside this sight glass right here, and see if we see that pilot flame. Now, that sounds easy enough.
Yeah, no,
right?
it's easy for us because it's on the desk here too.
Yeah, if this is what you were working on, no problem at all.
Yeah.
But you guys know how this is. Where's the water heater at? Well, especially in an apartment complex, if you're doing facilities maintenance, this thing's probably in a hallway, in a closet, and what else is in there, right?
Everything
Winter
else.
coats, Christmas trees.
Everything they can shove in there.
Yeah, absolutely. You're going to have to dig through that stuff and then try to look inside this little glass and see a pilot that is very, very small, and it's completely dark in here. Now, if the lights are on in the hallway, typically what's going to happen is you're going to look in there and you're going to see an eyeball, right? Don't panic, it's yours. But it just acts like a little mirror, so you see that reflection. So you may have to dim the lights in the hallway or something like that so you don't get that reflection. But all we're looking for is really just a clear blue light, kind of like an LED type light. Clear blue could either be to the far left or far right when you look inside that window. So just kind of search around to see if we see that light.
Typically, you'll look up and to the left or up and to the right, you'll see it. And it's just kind of glowing is what you'll see, because sometimes there may be the pilot tubes in the way of the actual flame, so it just looks like it's glowing.
Yeah, a lot of people look in there and they think, well, I'm looking for this big actual flame, like you would light a lighter. The problem is as water heaters have got more efficient, one of the ways that we've done that is reduce the size of that pilot, right? Because that's burning 24 hours a day in the bottom of the water heater. If we can reduce the size where it's still enough to light the main burner, but we can reduce some of those BTUs, then we can increase the efficiency of the water heater. So we're not looking for a big, large flame. It's just going to be a clear, dim blue light.
All right. So once we look through there, and let's just say that we don't have a pilot, the first thing we're going to want to do is just relight the pilot, right?
Yeah, absolutely. If we look in there and we say, nope, I have no pilot whatsoever, then you want to go through those lighting instructions. Now, you're going to find some lighting instructions right there on the front of the water heater itself. But really what we're doing is we're just going to take our piezo igniter. This is the igniter right here. This could be attached to the gas valve in a couple of different ways. Depending on the specific model that you're working on. It could be over here on the side, it could be on the top, it could be integral to the valve itself. It may be a button that you actually push that's attached to this. But that is going to attach to the igniter wire that comes down inside the, yeah, let's plug this in, see if we can get an actual spark. Can we get a close-up on the igniter right there and see if we can get this guy to spark? Really difficult to see, kind of hard to see on camera here. But all we're looking for is just a little spark that jumps from this electrode over to the pilot orifice. That's what's actually going to light the pilot. So we just want to walk through those lighting instructions and see if we can get actual ignition on the pilot itself.
Yeah, you're either going to light it or you're not.
That's right.
I mean, that's what's going to happen. It's either going to light or it's not going to light. If it does light, then you're going to go ahead and follow the steps and go ahead and turn on the water heater and it'll start back
Sure,
up.
absolutely. Once we got the pilot on a mechanical valve, you're going to want to hold in on your pilot knob, right? Because in order to light the pilot knob has to be in the pilot position and then push down. That starts purging gas through the pilot tube. And then we're just going to click off our igniter until we see that actual ignition. Now, once you get it, you want to hold down on that button for around 90 seconds, right? You're giving that thermocouple time to heat up to hold that power head open inside the gas valve. Then once you can let go, pilot's lit, now you can light the main burner and you're off and running.
But what's going to happen is what we're talking about is if we're looking through there and we can't get it to light. So we're holding down the knob and I'm hitting the igniter button and I'm looking through the sight glass, but I don't see a pilot at all.
Okay.
That's where we're looking at. So this is the first situation. So I'm looking through the sight glass, holding down the knob, and I'm clicking my igniter button, but I see the spark, but I don't see a flame.
Now we need to default to our flame triangle, right?
Okay.
What three things do we have to have combustion? Well, we need a fuel source, we need an ignition source, and we need oxygen.
Right.
Now, we assume if we're living and breathing around the water heater that we have oxygen. We can physically see the spark. The only unknown here is the fuel.
Okay.
Right? So if I know I have oxygen, I can see a spark, I have to assume that I'm not moving gas out of that pilot orifice.
Okay.
Now, that could be for a couple of different reasons. If this is a brand new installation, we may not have purged the gas properly, right? We're going to have to get all the air out of the gas lines and get a good steady flow of fuel up to the pilot orifice before we ever get ignition.
Yeah, because that pilot orifice is pretty small, and if you've got air in that gas line, it could take a little while to get that out.
It absolutely could, especially if you're purging it through this button.
Right.
A lot of times, well, I'll just purge it from here. The pilot orifice moves such a small amount of fuel, it will take an extremely long time to purge this efficiently through here. One of the best ways to do this is if it has a drip leg or a dirt leg right there on the gas connection, is just loosen that cap until you smell fuel. Now, once you do, close it off and walk away from the water heater. Give it 15, 20 minutes, to kind of dissipate before you come back and light it. You don't want to get into a situation. So give it time to dissipate and then go ahead and light it as normal.
Okay. So it looks like more like a gas problem. If you walk up to the water heater, you're trying to light it, you're holding down the pilot knob, and you can't get the pilot light to light. You start looking down the gas road. It could be a shutoff valve upstream. It could be air in the gas line. It's something on that side. Now, okay, that's on if we can't get it to light. Now, if we can get it to light and we're holding it down for the 90 seconds or 60 seconds needed to energize that gas valve, when we release it, it goes out. Which way do we go from there?
Yeah, if we've held this down for long enough, and again, anywhere from between 60 to 90 seconds, we have to let that thermocouple heat up enough to produce enough voltage. That voltage comes back through to the gas valve. But in order to get there, it goes through this safety switch, this door switch right here on the manifold door right there. All of the voltage runs through that switch before it comes back to the gas valve. So if I am losing pilot as soon as I let go of this knob, right? I know I'm making a pilot. I know I'm producing heat on the thermocouple. I should be producing voltage. If this won't hold, my immediate assumption is something is impeding the electricity from getting back to the gas valve. Now we're looking at the electrical side, right?
Okay.
If we see spark but no flame, it's gas. If we have spark, we have flame, but the valve won't hold, it's electrical.
Okay.
Right?
All right. So we're
going to
looking
go
at
to
the
our door
electrical
switch.
side. Okay. Go ahead.
Yeah, just come down here to our door switch. Now, the first thing we want to do is just see if this tripped. There's a little button right in the center of the switch itself. Let's see if I can turn this. There we go. There's your button. So what we want to do is just push in on this. Now, it will click just a little bit when you push on it. It's kind of hard to detect.
If it is open.
Yeah, if it has tripped. It's a little bit difficult to click or feel when it clicks. So just push it on that. You probably will feel it. And then just go ahead and try to light it again. Now, if it works, then you know that it was tripped.
All right, so that's the first thing I was talking about. Okay, so our electricity, when we're lighting the pilot, that electricity is going through our door switch from our thermopile. But let's say we press that, and we can test that. And really, we want to talk about testing. Now, for the first, before we get into that, we got to have the right tools. And I kind of got thrown off at the beginning because of the
It was a sweater thing, wasn't it?
In order to do any type of testing, you have to have the right tools. And we're going to talk about these tools. Let's start with
we've got a couple of different kits.
This is an actual electrical test kit that is available through HD as well.
Yeah, this is an electrical test kit right here that our friends down at HD Supply can get you hooked up with. This is a really good kit, especially if you do a lot of these. I know you guys work on a lot of different things, but if the water heater is kind of one of your normal products, this is a really good kit to get a hold of. It'll do the majority of the testing that you're going to run into on the water heater. It's not very expensive. small parts, throw it in your toolbox. Really, really good to have.
All right, and let's talk about this clamp-on meter, because this clamp-on will actually do everything that we really need to do. It'll do volts, millivolts, and actually it's got a clamp-on amp meter on there if you do any kind of like work on electric water heaters as well.
Specifically, if you're working on electric water heaters, maybe even power vent water heaters, this was, I would consider, a little bit of an upgrade over that one. But again, it's going to give you a lot more functionality. And you guys know it's all about having the right tool, right? It's all about having the right tool. That's what's going to make that job a lot quicker, a lot easier on you, get you in that job and get you out. So again, the folks down at HC Supply got you covered here as well. Just take that part number, go in and say, hey, I need one of those clamp-on amp meters because I'm tired of doing it the hard way, right?
And also we have one more, since we are dealing with gas, got to have a digital manometer.
Yeah, this is really a must. When you're working on a gas water heater, the old slack tubes, if you've been in the business for a long time, slack tubes have been around forever. They work, they're accurate. The problem is the low amount of pressure that we're testing. Slack tubes are very difficult to determine. Like, say, what's the difference between 3 inches and 3.2
Exactly,
inches, right? That's hard to do
yes.
on a slack tube. But with a digital manometer, all you have to do is plug this in, turn it on, bam, it's going to show you exactly what it is. So this is really a must if you're working on gas water heaters. And again, our friends down at HC Supply got you covered. Yeah.
Tenths of inches of water column.
Absolutely.
Get with that. That's great. All right, let's get back to the heater. So we're talking about electrical. So we're going to have to be able to test to make sure, because you might not be able to feel it if it did click. Let's say I'm releasing the knob, the pilot keeps going out, and I know that my power goes through this button, this switch, this safety switch, but I'm not sure that it, if it's tripped or not.
And it is hard to tell. Like I said, you can push on this, you may feel it, you may not. It's a little bit difficult to tell whether or not it has reset or not. Fortunately, as long as you have the right equipment, it's really easy to check.
Right.
All you have to do is pull the flag connectors off of this, get those out of the way, take your digital multimeter. You're going to set this to continuity, right? Because all we're looking for is whether or not this switch is in an open position or a closed position.
Okay.
Right? Now, its normal state is closed. It only activates, again, it's a safety switch. So if the combustion temperatures inside the combustion chamber start to get elevated, they get too high, the switch is going to open up. So its trip is to go open. So we just want to figure out what state that it's in. So we want to set our meter to continuity, and you can always tell when you're in the continuity setting, you touch your leads together, you're usually going to get a beep. On your meter, it's going to look like kind of the Wi-Fi symbol on an airplane or a speaker type symbol. Again, that's just telling you that you're in continuity, and it tells you, do I have an open or closed circuit? So we're just going to take our 2 leads and go into this switch, and again, get those flag connectors.
We've got to have those off, though. The flag connectors must be off, right? Okay.
And then we're just going to put 1 probe to either side of that switch.
Okay.
And again, if we get the bell to ring here, then we know the switch is closed. We've got continuity across the switch. If the bell does not ring, we got no continuity across the switch when we know it did open.
Okay. All right, so let's just assume that we do have continuity. The switch did not trip. We've checked our connections. And a good way to check the connections, when they say check the connections, a good way to do that is just take them off, the flag connectors off, and put them back on. That's a great way to check. Just take them off and put them back on. If there's anything, any debris or anything built up on there, it's going to knock that off. And if it's not seated properly, you're going to get that.
And believe it or not, a lot of times, especially when we're dealing with electrical, the physical act of removing that and replacing it fixes it. And you go in there and you take everything off, you put it back on, and it works, and you go, well, I don't know what I did, but it's working. As you pointed out, just clearing off those contacts, removing that connector and pushing it back on there kind of cleans that contact off. Now we get a much better electrical contact. A lot of times that'll fix your problem right there.
And you can do that before you even break out your meter. I mean, that's something you can do with your hands before you have to do anything else, is just go ahead and check those connections first. And then, if it's still not working, go ahead and bust out your meter and test it that way. But we've gone ahead and we've tested that switch, and the switch did not trip. It's closed. I'm still holding my pilot knob down for 60, 90 seconds. I still have a pilot, but when I release that knob, it goes out where am I going from there?
Again, we're still going down the electrical path,
Okay.
right? We know we're on that side of the equation right now. We know the electricity passes through the switch, so we check it, get it out of the way. Well, where does the electricity come from? Well, it comes from the thermocouple.
Okay.
So next thing we want to do is figure out how much voltage, if any,
Okay.
the thermocouple's actually producing. Now, we're going to have to remove this from the bottom of the gas control valve, right? Get that away from it. Now, here's the important thing. The pilot has to be lit. In order to see the voltage that gets produced by the thermocouple, the pilot will have to be lit. This gets a little bit difficult. You're going to have to light this the way you normally would. The problem is you're not going to be able to let go.
Okay.
If you let go, the pilot's going to go out.
Okay.
Right? Now, the reason this is difficult, we need to test the actual thermocouple, which means we're going to have to now take our meter and we're going to set it to millivolts. DC millivolts
Right.
is what we're looking for.
All right.
So we're going to, again, DC, and it's going to produce millivolts. And what we're going to have to do is, again, take our two leads, and we're going to put one lead to the very tip, the steel part of the thermocouple. The other part is going to go on the copper tube itself. Okay, now we're on both ends. Now this will tell us what voltage that we're producing. Now again, pilot has to be lit, so you may need a clamp to push down on this.
Or some alligator clips, maybe.
Alligator clips will help.
Yeah.
If your meter has alligator clips, you can clip them on. That way you can hold this down. You may need a buddy, right? You may need a buddy. If you don't have a buddy, I'll send you mine. You just have to feed him.
That's an old joke, y'all.
It is. Hey, you work with what you got. You know what I mean? So just check the voltage here. I've always said you need a third arm to
Yes,
kind of
you
do
do.
this test on mechanical. So
But not your
alligator
chest
clips
to do
really,
this.
really help.
Yeah.
But again, just check your voltage. What we're looking for is anywhere between 10 to 30 millivolts.
Okay, that was my question. So we're looking between 10 to 30 millivolts on that. So if we're not getting that, then we know what our problem is.
Yeah, 10 is really an important number. We say 10 to 30 because out of a standard pilot, 30 is about the max you're going to get. That's about all the heat it's going to make. But the really important number there is 10. Anything above 10, you're good. Anything below 10, you need to go ahead and replace the thermocouple.
Okay.
And that will happen from time to time. According to Honeywell, the average lifespan is about 100,000 hours. Well, if you do the math, that's about 10 years worth of operation. Now, for years and years and years, we would hop out of the service truck with a thermocouple in your back pocket.
Yep.
You knew that's what it was. About every 10 years, you had to go around and replace them. Not as true today. And
No,
we'll talk about that a little
yeah.
bit more when we get into electronics.
Yeah, you used to have you have a thermocouple and a gas valve.
That
It's
was
one or
it.
the other. I mean,
That
it's
was
going to be
it.
one of the two. I mean, we've got the thermocouple, and I've got one pulled up. You want to pull that up? There's a part number for that. So if you're not getting 10 to 30 millivolts, that's what you're looking at. You might as well go ahead and replace that thermocouple right there.
Yeah.
So if we're getting 10 to 30 millivolts, and we're we are getting 10 to 30 millivolts, and we know our door switch has not tripped, and then we've already unplugged this, we've unscrewed this, we're going to put it back in there. So we're going to maybe the connection could have been bad at one point. I don't know. It maybe pulled away a little too far.
You made a good point there about connection. If we're producing the right amount of voltage out of the thermocouple, one thing you want to do, make sure that this thermocouple has not been over tightened in the bottom of this gas valve. Finger tight and 1/4 of a turn. That is all that is necessary. If you compress the head of that thermocouple, it's going to squeeze off the voltage. You won't see anything, and the power head won't work. So again, just finger tight, and then 1/4 of a turn with a wrench. That is as far as you need to go, and that should produce the voltage. Now, if you've checked all of that,
Right.
I'm finger tight, I'm 1/4 of a turn, I'm producing 10 to 30, door switch is closed, everything is good, right? Now we can assume that we probably have an issue with the gas valve. Could be a couple of different things. Maybe the power head went out, maybe an internal failure of one of the valves, maybe the ECO maybe failed for whatever reason. But if we have checked everything, and we know everything is checking good, I'm getting 10 to 30, it's not over tight, door switch is closed, then I'd be looking at the gas valve. That's going to be rare. Okay. These things are bulletproof. They hardly ever fail. But if I've checked everything else, right, process of elimination, once I've verified that everything else is working, the gas valve is the only thing that's still in play, now you want to look at changing your gas valve.
Yeah, we've got one pulled up if you want to go ahead and put that up there. That is a rare case. If that does happen, there's the part number for that. But you know, we have call centers here. We know what's out there, and it happens from time to time.
Yeah.
We
And
do
these
get
are still
calls.
readily available. Again, we kind of started migrating away from the mechanical style roughly 5 years ago, but there are still literally thousands,
Well,
hundreds
yeah.
of thousands of these out there in the field. So you don't have a problem still getting these mechanical valves if that's what you're working on.
So what we're talking about, and we're moving to step number 6, if you're following along with our PDF here. On step number 6, we're talking about if the door switch, didn't, this is if we didn't trip, we check the thermocouple. If it did trip, is a different story now.
Yeah, again, this is a safety switch, right? So if we check that and it is open, again, its normal state is closed. So if it is open, we verify that with our meter, we see it's open. The first thing we have to assume, because it's a safety device, we have to assume it's doing exactly what it's designed to do, right?
Okay.
It's trying to communicate you. It's trying to tell you that the water heater is operating in an unsafe environment, so we need to take action.
Okay.
If we see that door switch is tripped, the worst thing you would do would just be reset it and go ahead and light the heater and walk away.
Yeah, just press it and just relight the water heater.
Yeah, sure.
Yeah.
Because
No.
it is a safety device, the water heater is trying to tell you that it's unsafe. Now, we know that it activates based on temperature. It's trying to tell us that the temperature inside the combustion chamber has gotten too high. Now, this is where we make heat.
Right. Why would it be a bad thing for this to get hot?
Yeah, why would we care how
Yeah.
hot the chamber is? Well, we don't really. In terms of temperature alone, that's not really the big deal. The big deal here is anytime that we're creating too much temperature inside this combustion chamber, then we know we have a ventilation problem. We know the water heater is not drafting the way that it should. Think about natural draft, right? Everything's moving up.
Right.
The air is hot, hot air rises, everything should be moving this direction. So the coolest part of the water heater should be down here at the bottom where we're bringing in fresh combustion air. If for any reason we start restricting that fresh combustion air, we're going to start overheating the chamber.
Right.
The big problem is as you start reducing the amount of oxygen that gets inside the chamber, now we run a potential of starting to produce carbon monoxide.
Right, because all of our air is coming through this flame arrestor here from the bottom of the water heater.
Yeah, see that flame arrestor right there in the bottom? This is where all of our air is going to pass. So if that starts to get clogged up with dust, debris, that type of thing, especially depending on where the water heater is located. If it's in a laundry room, think about what else is going on in the laundry room, right?
You're doing laundry.
Yeah, you're doing laundry, so you got lint, dust, the dust bunnies, everything else can get clogged up in there and start restricting that airflow. As long as we got sufficient air, the water heater as a byproduct is going to produce carbon dioxide.
Right.
If we start reducing the amount of oxygen that can get inside that chamber, then we can start producing carbon monoxide. Completely different game now.
Right.
Right? Much more dangerous. So that is what that switch is really there for. It's a carbon monoxide detector.
Okay.
Right? Now, we could run an actual carbon monoxide detector, but then you'd have to plug the water heater in. We know that 80% of the market is a replacement market, so having to change design is not really favorable. But because those two things are always linked, because the temperature and the carbon monoxide production always go hand in hand, all I have to do is check one. Well, it's very easy for me to check the temperature. All I need to now is a temperature switch that activates at a certain temperature.
Yeah, and we know what that is.
That's what we've done. So if this is tripping, I have to assume that the water heater is not getting enough oxygen.
Right. Okay, that makes sense. And there's something, what we're going to do now on number 6, if you look at the electronic, it's the same thing. So what we're going to do is we're going to go over to the water heater and do the electronic gas valve. And when we get to step 6, we're going to do it one time, and that way we don't have to do it twice. So we've got, looks like we might have a question here. Okay, I think it says, will you there you go. The water heater that we have doesn't have the safety switch where you're showing. I know it's a different model, but how do I locate the safety switch, and would mine even have one?
That's a very good question. It really depends on the age of the water heater. If it's older than 2003, that's going to be what's referred to as a non-FVIR water heater. It's going to have open air combustion, which
You
means it's
wouldn't
going to
have
have
this
holes all the way
door right
around.
there, yeah.
Yeah, you would just be able to access the combustion chamber very easily. It'd be wide open. If it's after 2003, there's a period between 2003 up to about 2007, first part of 2008, where there's several different designs out there. There was another style that the safety switch was actually inside the combustion chamber underneath the burner head. That one is self-resetting. You don't have to reset it. There you
Actually,
go.
I have one right here.
There you go.
We have one right here.
There we go. If we can get a close-up, it may be a little bit difficult. But here is the safety switch on this one.
Here, I'll tilt it up just a little bit. Can you see?
There you go, right there. And what we're looking, that's just a little bimetal disc that is soldered in line into the thermocouple. Now that one's self-resetting. You don't have to reset it yourself. It will do it on its own. The only problem with that one is you don't actually know when it tripped and when it did.
Yeah, because you would go to the water heater, you relight it. By the time you relight that water heater and you find out you have no hot water and you've used all the water or hot water in the tank, it's already cooled off and reset itself. So when you relight the water heater, it's going to light again. And then it's going to heat up, do the same thing. It's going to open up, and by the time you find out you've already ran out of hot water, then it's reset itself, and you just keep repeating that process.
This design here ran between 2003 up to the first part of 2008. This mechanical style, what we refer to as the next gen, started in 2008 and run up to the latter part of 2010 to 2011, and then we went into the electronic version that you're going to see a little bit later. So depending on the age of the unit, you may or may not have a door switch.
Yep, and you can see the front of the water heater is different. There is no door switch, like he said. Also, the flame arrestor on this was a little bit different. It was more of a quarterite, is a quarterite stone that's in there. It's got many little holes. I don't know if we got a good shot of that or not, but it's right here. This is really nice. There we go. So all the air, same principle, all the air is going to pass through this.
Yep.
On this one. All right, so what we're going to do now is, once you grab a couple test meters.
Let me set this.
And we're going to go over to the electronic.
Yeah, we're going to step over to the water heater again and show you a couple of more things. Now, what we were talking about earlier about the airflow, that door switch tripping on the water heater, those flame arrestors that we were just talking about, if they start to clog up, then we may have to go in there and clean those, right? We may have to go inside the bottom of the combustion chamber, clean off those flame arrestors, regardless of which style, whether it's the C3 design that ran from 2003 to 2008, or the mechanical style, or the electronic style. Either one, we're going to access this through here and clean this flame arrestor out. Now, you can check to see whether or not we're getting enough air. We're going to talk about that a little bit later because we had the exact same test on this water heater as well. So at the end of this troubleshooting, we're going to show you what's called a draft test. That test is going to apply to either one of these water heaters. So we're going to show you that.
Yeah, it's step number 6, and we'll kind of go through that whenever we get to that step. But that way we don't do it twice. We're going to show you with this heater right here. Got another question here. What's the correct section? Section reading on the manometer? And he may be talking about.
Yeah, I think we're talking about gas pressure, right? If we're gonna check it.
Suction is section. I thought it said.
Correct, suction. We're talking about vacuum, right? I assume we're talking about vacuum. In terms of these water heaters, the one that we're working on today, they're all going to have a positive gas pressure.
Right.
There's going to be 2 different ways to check gas pressure. You can check it on the manifold side. You can also check it on the supply side, right? Supply meaning coming into the gas valve. Manifold meaning coming out of the gas valve into the burner. Now, in terms of pressure, this is normally measured in water column, like we were talking about earlier, that we would check with our digital manometer. It depends on the gas valve that you're working on. Manifold pressures, meaning the pressure coming from the gas valve out to the burner, will be anywhere between around 3.5 up to 6 inches water column. somewhere in that range.
Just
it depends on the valve.
the valve, yes.
You'll be able to find that on the valve itself. There'll be a sticker on the valve that's going to tell you what the manifold pressure is. Now, your supply pressure coming in will be anywhere between, say, 3 inches up to 14 inches coming in. You want at least 1 inch above the lowest manifold pressure.
Exactly.
Meaning if the valve requires 4 inches of manifold, then I need at least 5 inches of supply. You need to allow for a 1 inch pressure drop when that valve opens. So supply pressure, if this was a 4-inch valve, then I would want my supply pressure to be between 5 and 14. 14 inches of water column is the max. Now that is on natural gas. If you're working on a propane unit, then your supply is always going to be 10 inches, right? 10 inches. I'm sorry about your manifold. Manifold's always going to be 10. Your supply is going to be anywhere between 10 to 14.
Right, and you know, we're talking about, you know, supply pressure. We really want it to be, you know, when everything that uses gas in the house is on, you don't want to see more than that drop, because really when you're talking about a drop in pressure, you know, you could have your gas pressure should be okay during the summer months and everything should be running fine, and then when we get into winter, when we turn on all the other gas appliances, you might have an issue with
that's a very good point. What Jerry's referring to is the difference between static pressure and dynamic pressure. If nothing is on, right, and we just check line pressure, what's the pressure inside the line? That's referred to as static pressure.
Standing still.
Standing still. That's one number, and that's always going to be your highest number. Now dynamic, again, dynamic movement. Now we have things on. We want to check dynamically, and we also want to check a worst case scenario, which means I want to turn everything on in the house when I check this, because I want to make sure that the water heater still has sufficient fuel, even when everything is running. Think about this in terms of your shower. If no water is running in the house, you have pretty high water pressure in the line. Well, if you open a shower head, a lot of water moving, the line pressure, of course, is going to go down. If you open another shower, then both of those showers are going to have diminishing pressure, right? The more demand we put on this system, the lower pressure we're going to get. That's what we want to check when we check gas pressure. We want that dynamic reading, and we want worst case scenario.
All right. All right, so let's get into troubleshooting. Again, the same thing applies, just like the mechanical style. We got to verify that we have no hot water in the entire building. We want to make sure that it's not, you know, I've got hot water in the bathroom, but not in the kitchen, and things like that. We want to make sure it's the water heater, and the water heater isn't.
Absolutely. As you always say, troubleshoot the call before you troubleshoot the heater.
All right, so the first thing we're going to do with this, if I verified I don't have hot water in the house, what do I do if I'm a service agent and I go to a mechanical style? What's the first thing I do on that?
Just like before with the mechanical, we're going to look inside our sight glass and see if there's a pilot. The cool thing about now, it's an electronic. It can actually communicate with you. So the first thing you want to do now is look at the valve, right? We've got a flashing status light right there that's going to tell you whether the water heater has a pilot, whether everything is on and working. So the first thing you want to do is just see what the water heater is telling you, if anything.
Right.
Now there's a high likelihood if the call is no hot water, you're probably not going to see anything here. But the key is this water heater can throw error codes, right? It can throw status codes to tell you if something went wrong. So the reason that you may have no hot water is because the water heater is actually in a fault, right? And you would see that with this flashing light right here at the status indicator. Say if the water heater was in an error code 2, which happens to be a low voltage on the thermal pile, then you're going to see a 2 flash on this status code, which means it's going to flash twice, and then pause, and then flash twice again. Now you know exactly what's going on. I see the status code. I know why I don't have hot water because I'm in a fault code. But if you do not see any type of fault code whatsoever, we would refer to this as the valve's dead. We got a dead valve. Now you want to go through your sight glass.
Yeah, because that's really the #1 status code. I mean, really, if they call in, #1 is no code at all. And to be able to throw a code, it's got to have a pilot. We got to be generating electricity. And if the water heater is off, it's not going to be generating any electricity, and you're not going to have a status light at all. So that's really it. You're going to see nothing. And when you see nothing, the first thing we're going to have to do is we're going to have to relight this pilot. But the cool thing, again, hey, we're dealing with electronic here.
Right.
We don't have to stand on our head and look through there for a pilot. Let's talk about lighting this pilot because it's different.
Yeah, when we want to light this one, again, this one's electronic, so it's going to light a little bit different. Now all we want to do is take this knob and turn it to the pilot lighted setting. We're going to push in on that. That starts purging the valve. Here's our piezo. Now it's built into the actual valve itself. And we're just going to click this off.
Okay.
And you just want to keep clicking this. You don't have to do it real rapidly, right? Just click it off, and you just want to keep doing this for about 90 seconds. Now, what we're looking for is this status light to start to flash.
Okay.
Once we see that status light start to flash, then we know that pilot is lit, and we can let go of the knob.
Release it and then turn
now
it on.
you can let go and go ahead and turn it up, turn the main burner on, and you'll start producing hot water now.
So we're really going through this just like we did on mechanical, and I mean you can follow along with the PDF. So we're going to be holding this down. The first thing, you know, if I'm trying to light this and I don't get a light, I mean I'm not getting a status light, then I will have to look through my sight glass.
Yeah, because now we need to see what's going on, right? We need to find out whether if the valve is actually accurate, or if maybe it's giving us some bad information. Maybe it's not able to see the actual pilot. So now we want to go to our sight glass, see if we get a pilot, and see if we get that spark, right? We were talking about that before. Again, this is going to be a little bit difficult to see. You guys know how this is. You get to the water heater, and half the time you're standing on your head with a flashlight in your mouth trying to look in the sight glass to see something. It's a little bit difficult to see. But again, you're looking for the pilot light, clear dim blue light, far left, far right. That's what we're looking for.
Another question here. Where is the drop leg on the gas line on this, the sediment trap?
Well, that's a really good point. Pay no attention to the man behind the curtain. These are just for our purposes here on the set. We don't actually have a drip leg, but it would normally be right there where that T comes down. Most guys will just take that T and extend a short 6-inch piece of pipe right there, but it could be anywhere. It's going to be at the lowest point. And again, it's usually just a piece of 6-inch black pipe with a cap on the end of it. So yeah, you kind of busted us on that one. We don't have one on the set. Actually, little do you know, it's not even black actual pipe. It's fully propped for us. But see, that's what these shows are all about. You get to see behind the curtain
movie
with
magic.
us.
All right, TV magic. All right, so so we're going to try to light it, and again, follow your steps. I'm going to be holding this down. If I don't see a status light, I'm still clicking the button. I'm looking through the sight glass. If I don't see a pilot, then I'm just going to do what we talked about on the mechanical side. I'm going to look at my gas, right?
Yeah. Is our main gas on or off?
Did we pay our bill?
Yeah. Did you pay the gas bill?
Yeah,
That's a very good question. You can always tell these because if the valve handle is sitting perpendicular to the actual gas line itself, see how now we're sitting crossways? Then I know the gas is off. So I just want to make sure that the gas is on, the bill's been paid, and has it been purged, right? Go ahead and purge the gas line, make sure we get plenty of fuel up to the valve itself.
Yeah, so I mean really, so you're going to go down the gas road if you're not getting a pilot trying to light, because you've got air, you got your spark, because you can see it in there, but you're just not getting the pilot, so we're going to start looking down the gas road. All right, so let's say I'm holding it down, and I've been holding it down. I'm looking here. I don't have a status light, but when I look through the sight glass, I do see a flame, and I'm still not getting this blinking light, because I have to, the way this valve works, I have to wait till this starts to blink to give me that one beat every 3 seconds. In order for me to be able to release the knob and turn it on.
And it's possible once it starts to light, it may go to a code, right? It may go one of these fault codes that we're talking about. And the fault codes are right there on the front of the gas valve itself, so you can see those there. So you can kind of line up how many lights is it flashing. This will tell you what code you're in. If you're getting a code, okay, if you're getting one of these codes, 1, 2, 3, 4, 5, 6, 7, 8. If you're getting any one of those codes, just refer to your manual and do what that code says. Those are very specific. That is the easiest troubleshooting there is. and the beauty behind the electronic valve, because if I have an error code 2, it's telling me that the thermopile is bad, then change your thermopile. Done deal.
Yeah.
If you're getting, say, let's look at the 7. This is a gas control or valve failure. That's an internal failure. You just replace the gas valve. Very, very easy.
Right.
The only ones that are difficult, as you pointed out, is when there's no status whatsoever.
Yeah.
So you may get a code, you may not. But if we're seeing a pilot inside the water heater, but this light never flashes whatsoever, again, now we know we're on the electrical side, just like on the mechanical style. If we're never getting ignition on the pilot, go down the gas road. If we're getting ignition on the pilot, but the valve is not coming on, then we go down the electrical road. So just like with the mechanical, on the electronic, we're going to go right back to our door switch.
Yeah, it's a little bit different switch. It's got this is got a little black knob on it.
Yeah, your wires go at a different location, right? Instead of going into the back side of the valve, now they actually go into the front. We've got this little door right here that's going to help you out a little bit later. But again, just push on that switch and see if it's tripped or not. And again, it's a little bit difficult to tell. There's your switch right there. And as you pointed out, the switch on that one is black, a little bit easier to see against the white ceramic of the switch. So just push that in, see if you get a click or not.
Yeah, so we're going to assume that it didn't trip. We're going to assume that it didn't trip, and we've tested it, and it's closed.
Yeah,
but
and this one tests the same way.
Yeah, okay.
You're just going to pop your connectors off,
yeah.
pop your flag connectors. Again, set your meter to continuity here because now we're testing whether it's open or closed.
Right.
And we're just going to take our meter and go to each prong. Again, we test it the same way that we do the mechanical style. That's going to tell us whether or not that switch is in an open position or a closed position. Now, if it's closed, then we assume that voltage is traveling up, so we're going to keep going. Now, just like on the mechanical style, it's actually even more important here is make sure that we have all our connections good and tight. Pull these flag connectors off, push them back on the heater, right? Wiggle them, make sure it's good and connected.
Check
when they
this.
come up to the front, make sure those are pushed in, they haven't been pulled out. Say somebody walks by the water heater and they get their foot hung on these wires or something like that because the front door is off. You could pull one of these connectors out, and now all of a sudden you got a no hot water call.
Right.
When it's just a connector, push the connector back in, you're good to go.
Yeah, okay, so door switch wasn't tripped.
Yep.
And we're still not getting a status code. Now we're going to go ahead and check. We got to check the thermopile output is what we have to do. But there's a good way of doing this because, like you said, the wires aren't coming out of the back. We don't have to disconnect really anything. We're just going to open up this door on the back.
Yeah, that's the cool thing about, again, the electronic valve. You pointed out, now we're checking the thermopile. A little bit different than the mechanical style. We're using a thermocouple on the mechanical style. Now we're using a thermopile. Sounds different, it isn't, right? Basically, if you could think of it in terms of analog versus digital, that's kind of the difference. It's just going to produce more power. It's called a thermopile. It's basically a pile of thermocouples is a good way to remember that.
Right.
You're just taking a bunch of thermocouples, binding them together in one housing, therefore producing more power. But because it's electronic, because it's, again, the difference between analog and digital, now all I have to do to check the output is I can just go right here to these flag connectors, right? Now I can go right here to these connectors and I can see what the actual voltage is right here.
Still, I'm going to have to hold down the pilot knob. I'm still going to have to, look through the sight glass. I've got a pilot. As long as I have that pilot, then I go ahead and put my leads on there, and I can look and see what the reading is. I think we got a question. Is there a difference between troubleshooting a home water heater, a water heater in the home, and a commercial water heater? And yes, there is. It depends on what kind of water heater you're dealing with.
It really depends on the technology.
Right.
That's going to have a lot to do with the age of both units. I would say in general, yes, your commercial water heaters are going to troubleshoot quite a bit different than your residential because it's different technology, different type of gas valves, different bells and whistles.
BTU input. I mean, you could be dealing with a 500,000 BTU water heater.
Yeah, pressures are a lot different. You may have what's called a zero governing gas valve that's going to run on a vacuum instead of a positive pressure. When you actually test it, you're hoping to see zero.
Zero, yeah.
Which is a little bit different. So again, yes, commercial is going to be a little bit different. On the website that you're on right now, there's actually a lot of of information on there about commercial water heaters. There's some troubleshooting steps, so feel free to check some of those out as well.
But you still have to have three things for combustion, though.
You still can't get away from the flame train.
Yeah, you got to have
right?
three things.
Got to have
that
air, fuel, spark.
Hey,
that
that works
change.
on all of them.
That's right.
So, all right, so let's get back to this real quick. Now, the door switch didn't trip. Now I'm going to have to check the thermopile output. We talked about that. It's a pile of thermocouples. So we've got around 20 thermocouples all built into one. And I think we have a shot on the desk there. We put a thermopile up there. I don't know if we can get a shot on the overhead shot. But it's a little bit bigger.
Yeah.
You know,
yeah, the tip is just a little bit larger again because we're putting, we need a whole lot more power because now we're running a board on the inside of the gas valve. Now it can throw light, it can communicate with us a little bit, so we need more power.
Yeah, we'll get it.
And by how much, we're talking quite a bit more actually.
Yeah, you're looking at anywhere between, really our magic number is 350. So we're looking at 350 all the way, but you could see 800, 700 millivolts, and that's a lot more voltage than the 10 to 30.
On the mechanical style, we said that 10 was the magic number, right? Anything above 10, you're good to go. Anything below 10, go ahead and replace your thermocouple. On a thermal pile that's going to run on your electronic style, 350 is a magic number. Anything above 350 millivolts, you're good to go. And you could see upwards of 900.
Exactly.
If you see anything below 350 millivolts, go ahead and replace your thermopile.
The hotter the thermopile gets, the higher the number. So
I'm glad you pointed that out.
Yeah, we're going to talk about that.
We talked about the fact that you have to light this. Before you actually do your test, right, and take your reading, you want to let this burn for, again, that 90 seconds, 60 to 90 seconds. Allow that thermopile enough time to heat up before you actually take that reading. Because if you check it immediately, it's going to be low.
Right, and it's not going to be one number. Like whenever you put your test leads on there and you're holding it down and it's lit, you'll watch it go up. It will just start to go all the way up to whatever number, and then it's going to kind of like taper off. But as it's heating up, the longer it's getting hotter and hotter and hotter, that number's going to climb unless
it's all about
wrong.
temperature.
Yeah.
So that number's going to fluctuate a little bit.
All right, I think I have a question here. Where can I buy the burner assembly for the 2010 and up model? I don't know if it's available.
Again,
HD
you want to contact your local HD Supply, see what they have in stock down there, tell them exactly what you need.
Yeah.
They're going to be best able to point you in the right direction, whether that store there locally has it or not. But again, reach out to your local folks at HD Supply. Tell them what water heater you're working on. Tell them what parts you need.
I mean, and if you're looking for like a thermopile assembly, I mean, they do have a thermopile assembly, and it's available. It's right there with the tubing. You can get that through HD Supply. You can also get the gas valve, which we'll get to in a moment. It's available through HD Supply as well.
And that's really all you really need is that pilot tube assembly. The actual whole, what we refer to as the burner assembly, which is the burner head, the manifold tubing, the door assembly, all of that kind of stuff. It is really, really rare that you would have to replace that. There would have to be some physical damage done to that, and that really doesn't really happen. The pilot assembly that we showed you a while ago is probably really the only part that you're probably going to need. There really wouldn't be any reason to replace the burner head and things like that again, unless it saw some type of physical damage.
Yeah.
So you
or
want
if
to go
there's
ahead
a problem with I mean, I guess the door. I mean, we're talking about the whole manifold door assembly as well? I mean,
there's not really a reason to replace that unless it's truly damaged. So stick with the pilot tube assembly. We showed you the part number on that one. If for any reason you actually do have some damage, again, reach out to your friends down there at AC Supply and tell them what you got and tell them what you're looking for. They'll be able to point you in the right direction. All
right. All right, so let's get back to this. So now we're going to check the thermopile output, and you know, we've made it easy. This gas valve is easy because there's a door on the back that you can open up. And with the newer models, they're actually this is all one piece. There are some out there that these two leads are separated. They're separate, and really you're going to have to look on there. You know, the wires do matter. If you put them on white over here and red over here, it's not going to work properly.
Yeah,
so,
red's your positive, white is your negative.
and it says it on the gas valve right there.
It's molded into the gas valve. So again, it's got the color and whether it's positive and negative on there as well. So just make sure you got the right one on the right side.
But they do have the little doors on the back. But with this one, it's all one piece. So we can open up this door, which makes it easier. So now we can light our pilot and use our test leads to go in from behind instead of taking this out and going, you know, because we can run the risk of you know, kind of stretching out this connection and making it loose.
Yeah,
which would be
we
bad.
could actually, to make a bad connection ourselves by opening up that flag connector or something like that. So that's why that door is really cool. It makes it much more serviceable friendly if you need to work on the water.
Yeah, and you can get your leads in there and with one hand and hold those leads and actually test that. So we're looking for 350 millivolts, and that's what we're looking for. That's our magic number. So if we're holding this down, and we've got to hold it down for at least the 90 seconds, you've got to give it time to heat up. You're going to see it on the multimeter. You're going to see those numbers rise. So just wait, and if it's over 350 millivolts, then you know that this is good. But if you're not getting 350 millivolts, and all of your connections are good, and you've been holding this down for 90 seconds, and that number has stopped climbing, then we know it's our thermopile. We'll need to replace the thermopile. But if you're doing this and you see this is all your connections are good, and you're getting 350 millivolts, and you're still not getting a status light, and you are getting 350 millivolts, and you're not getting a status light, when you release that knob, it goes out, then we know it's the last thing. It could be, it's the gas valve.
Yeah, then it could be the valve. Just like the mechanical style, if we've checked everything, and again, this is going to be rare that you got the gas valve failure, especially without a code, okay? But it is possible. But if you have checked everything, my door switch is closed, I'm getting at least 350 millivolts because my pilot is lit, now you want to look at the gas valve.
All my connections are good. Yep.
Yeah, and I think we have a gas valve over there to show you as well.
Yep.
There's a gas valve.
There it is.
There we go. There's an electronic gas valve. So if we've checked everything out, now you want to look down the gas valve road. But again, here's the most important thing. Again, whether we're looking at mechanical or electronic, if the pilot will not light at all, meaning no combustion, go down the gas. Maybe the gas is off, needs to be purged, whatever. It's on the gas side. If I have pilot flame, but the valve is not coming on, then I'm going down the electrical side. Check my door switch, check my output on my thermocouple and thermopile, either 10 to 30 or 350 millivolts, right? And then look at the gas valve. But those procedures are the same. Now, where you check it is going to be a little bit different depending on mechanical and the electronic. Now, the last thing we want to show you, we kind of alluded to it earlier. If this is tripped, just like on the mechanical style, we need to figure out why. It's a safety switch. So we have to assume it's doing exactly what it's designed to do. It's telling us that the water heater is in an unsafe environment. We want to clean flame arrestors. Make sure that we get all dust and debris out of the chamber and off the flame arrestor.
You've got a filter here. Make sure the filter's clean. You've got your flame arrestor under there. You're going to want to clean that flame arrestor. But you've got an issue. You've got an air issue, some type of an air issue. Either you know, you're not getting air in here enough, but it's causing that door switch to trip.
Yeah, and as you pointed out, there's a couple of different styles here. You may see a base ring style that we're looking at right now that runs like the filter belt that slides through there. That is going to catch all your main debris. Some water heaters have feet underneath that have kind of the belt that wraps around it, external plastic that goes around the bottom. Again, those are all there to catch the big dust bunnies, things like that.
We've got a question here.
But get all that debris out, make sure this filter's clean. You want to use like a household brush, baby bottle brush, toilet brush, something with a good long handle, and clean out that flame arrestor, get any of that dust and debris out of there.
All right, let's see what we got here. Where do I plug the manometer in on the electric valve? And it's talking about, I guess he's talking about manifold pressure.
Yeah, what you're going to need when you get your manometer, you're going to have some adapters, right? Some threaded adapters with a barb fitting on them.
Just you stay here. I'm going to get that for you.
Okay. How about I stay right here, Jerry?
Yeah, why don't you stay right there, and I'll get that for you. Yeah, we've got a couple things here I can show you. I've got a valve right here.
This will be perfect.
Yeah. And this is what comes with it.
Yeah, here's your barb fitting. See if we can we get a close-up of that? There we go. There's your actual barb fitting. And all we're going to do is slide this into the tube for our manometer, right? We're just going to plug that in. Then we're going to take our gas valve, and on the bottom of the gas valve, see those ports right there? This is where our manifold would go in at. What we're looking for is this test port. So all we want to do is take our manometer. Now that we've put our adapter on, this is our pilot right there. There's your manifold, and there's your test port. So we just want to go into the bottom of the gas control valve, screw that into the test port right there. And again, on the main valve, what we're looking at is right up underneath the gas valve itself. But we're just going to screw this in. And then just go ahead and light the water heater as you normally would. Now, you need to have your main burner to come on before you start seeing that manifold. Now, on the supply side, we talked about that a little bit too, checking the supply. If you check manifold pressure and that manifold pressure is wrong, right? We see that the valve has to have 4 inches of manifold. We check it and we see it's got 3. Don't assume that the gas valve is bad.
Right.
Because if the supply pressure is not enough, you're not going to get your right reading. Now, if it is, if you check manifold and it's good, no reason to check supply. You don't have to bother with it. But if your manifold pressure is not good, it's too low, now you want to come back over and check supply. That one can be a little bit difficult depending on your access, how you're going to check that supply. Some people do this from the dirt leg. There's a couple of ways that you're going to do this. It depends on your specific application and what's going to be accessible to you as you check that supply. But again, you need at least a 1-inch pressure drop across the valve. So if the valve calls for 4, you need to see at least 5 over here. So if you're not getting 4 here, go back to supply, see what that is.
Yep, very
Hopefully
good.
that answers your question.
Very good.
Now,
All right,
we
let's
talked
talk about that. It tripped.
Yeah, we talked about the trip. We talked about the importance of cleaning out the filters down here. And the name of the game here is getting fresh air into the water heater so we don't produce oxygen. Now, we talked about that there's a way to actually test this.
Right.
To see whether or not we actually are getting fresh air into the water heater. Now, this is true whether we're dealing with the mechanical style or the electronic style. What we want to do is come up here to our draft to it. Here's our draft to it, and we want to do what's called a draft test.
Okay.
Now, the first thing to remember when you're doing a draft test, the water needs to be running for at least 5 minutes.
Okay.
Okay.
The water heater needs to be running.
Yeah, the water heater needs to be running.
The water needs to be running. That's good. Okay.
Yeah, it needs to be on, fired up, right? Producing heat. For the first 5 minutes, there's a strong likelihood the water heater is going to, what we refer to as spill, right? Before the vent system heats up, before the water heater starts to get good and hot, we may start spilling some of the combustion product out of the draft hood. That's perfectly fine for the first 5 minutes. After 5 minutes, we should be producing natural draft.
You should start drafting within that.
We should start drafting. Now, the way to tell that is we're going to need something that will produce some smoke.
Right.
Right? Maybe this is a cigarette. Maybe it's a piece of a punk, like a fireworks.
That's what that is in that picture right there.
Yep, that's what it is right there. Or even a piece of paper that you light and then kind of blow out, anything that will produce smoke. And we want to hold that right outside the draft hood, not under the draft hood. We want to see if the air traveling past that draft hood will actually pull that smoke in and up. In and up is what you want. If it's hanging around the outside and never gets pulled in, then we know we have some draft issues. The water heater's not drafting properly. That could be on the venting side.
Right.
It could be on the airflow side here. Worst case scenario would be that smoke coming in and going down. That would be even worse.
Right, but one thing that you need to keep in mind is you need to shut all the doors and windows to the outside. Make sure everything's shut. All your vent fans that are pulling air out of the house, turn them all on. So we're pulling everything out. We want to make sure that it's in the worst case scenario when we start this water heater.
Just like when we took our gas pressure readings earlier. We want worst case scenario here, we want dynamic. Dynamic means We want to close all doors and windows, right? And turn on anything that moves air.
Right.
Right? Because we want to give the home the most negative airspace that it's ever going to see, which means turn on your range hoods, your vent fans, anything like that, close all the doors and windows, and then do your draft test, because you need to know that that water heater is going to work in any situation. And that's how you do that.
That's your draft test. So, and really that applies to both the mechanical and the electronic. That's why we kind of saved it to the end. But that's going to tell you if this water heater is working properly, and if why this tripped. I mean, because we're not moving the air.
That's right. Exactly right.
All right. Just want to check one more time. We're going to go back. Let's go back over to the desk real quick.
Let's do that.
And we'll kind of wrap this up. All right. Now, I was just going to show you here. This is your thermopile right here. If you want to get a shot of that overhead real quick. There we go. And we're talking about, it's a larger piece of metal. That's why we call it a thermopile. Pile of thermocouples. So.
But it does the same thing, no different, just produces a little bit of voltage. It's just going to produce a little bit more than your standard thermocouple again, so we can run that electronic control.
All right. Well, we got another question right here. Okay, are these training videos available for customer training? Customer training, and I guess we're talking about really what they mean by that. I mean, you're on that website. I mean, we've got over 100 videos, I think, on that website that they can go to, and really you can kind of watch whatever we have up.
Yeah, that site you're on is public. So when we say customer training, I assume we're talking about a tenant or an end user or something like that.
Well, that's true.
Technically, they could see them. The only thing that I would kind of hesitate to say yes about is they are not specifically designed for an end user or a tenant. So a lot of that material, while you as a service provider are probably going to be familiar with, they probably are not. Again, they're not made for that specific audience. So I'm hesitant to say yes. Now, could they have access? Yes, they could go to the same place you went and they could see it. I don't know that they're going to be familiar with all the terminology and the things that we're talking about.
Well, and another thing too, I mean, I don't think that we really advertise it for them to go to something like this at all.
We do not.
It's kind of difficult for them to actually find it.
Yeah, we do not want to circumvent you in that scenario.
Right, exactly.
Okay, that is your customer. That's who you're dealing with. Yes. We do not want to go around you in that scenario. Yeah. So we do not market that directly to the end user or tenant. We would prefer you to stay in that equation as opposed to cutting you out.
Yeah, because if you watch them, they're not for end users, really. I mean, the actual homeowners or tenants, no. All right, well, really, that's our show for today. If you have any questions about anything we've covered here, remember, though, before we get any more, you can go ahead and download those PDFs, keep them with you. They'll be great. Put them on your truck. They're great to have.
Yeah, guys, print these out and keep them. Keep them in the service truck. Maybe you've got like a little folder or something like that with manuals in it or something like that. Have this with you, because you run into these water heaters and you're thinking back, man, I saw this show.
Yeah, no, it's just, you don't do this all the time.
Talking about something and then I can't remember what they said. This right here is a step-by-step procedure that will walk you through everything that you need to know. Again, get you on that job and get you off that job as quickly as possible.
Yeah, and it's all
with
about
this paper and the great tools and assistance that AC Supply helps you with, we're going to get you on that job and get you off.
Yes, we will. All right, just email us if you have any questions about anything we've covered here at university@hotwater.com. If you have folks who missed this broadcast, a recorded version will be available in about 24 hours on our HD Supply page, university.hotwater.com/HD Supply. Well,
that's it. Again, from everyone at the university and at AC Supply, we would like to wish you and your family a happy holiday season. Happy holidays to you.
Happy holidays, Jason.
You guys be safe out there.
For Jason Littard, I'm Jerry Winslet. We'll see you next time.